what's up everybody? Welcome to my first Touchdesigner tutorial. I kind of want to do my tutorials a little differently than the typical walkthroughs that you see, just because there are already quite a few really good teachers out there doing that style of tutorial, and so I don't want to, I guess I don't want to tread on ground that's already been walked, so to speak, nor do I want to step on the toes with those people because I learned from a lot of them. So what I kind of wanted to do instead was, and this will be the easiest way for me to generate a lot of content around this stuff too, was to kind of screen record my Touchdesigner noodlings, as it were. I'm going to try to have kind of focused noodlings, but I'm still going to start a project from scratch and we're going to try to achieve a result. Reason I'm going to do it this way is because I think it'll be a more unique learning experience, and you may, wind up stumbling on some discoveries along with me, just about things I haven't tried, or, tiny variations in generative art can yield really wildly different results. So, sometimes we get lucky. All right. Anyway, so what I wanted to try to create today was something like what I have going on in these sample videos I have here. This kind of rippling water looking, sorry, I forgot there's music on it. Here, let's see if I have one that doesn't have music. I don't think I do. All right, we'll turn the volume way down. So most of these are audio-reactive, and part of the reason for that is because this water texture right here, the kind of ripples, work really well with audio-reactivity, and it's kind of become a go-to texture for me. This one's got a light background, so hopefully the compression doesn't totally destroy it, but you can see them operating in there as well. Let's check out this one. Turn that down. So you can really see it playing nice with audio-reactive elements in this one. You notice as the chords hit, the ripples get a lot bigger and more chaotic, and then as the chord tapers off, as the envelope of that sound tapers off, they get a lot more gentle, and you get this more consistent rippling, just kind of like a calm ocean. So I got a couple other examples of this. Pretty similar setup here. And then turn that down beforehand this time. There it is. So anyway, super trippy, super cool. Very simple technique as far as achieving the look. You may have noticed that it's not really. I guess it's not. I'm losing my words here. You can use it with any kind of input. So whether you have an entire 3D geometric scene that's happening underneath all of this, like in the case of this, or you just kind of have like a noisy texture in the background, this will still work on any of those. This one's more of a noisy texture with a feedback loop that is getting pulsed and reset, tied to the kick drum in the song that's playing. But anyway, you can see the ripples are part of it. So yeah, I'm just going to show you how to create the ripples. We'll see if we can make something cool. All right. So I should probably preface and say that this is going to be more for intermediate Touchdesigner users, people who are already somewhat familiar with the interface and can kind of find their way around. If that is not you, if you're just a total noob to this, then I would recommend going and checking out Electronaut's Touchdesigner beginner course. I don't know too many people who use Touchdesigner who didn't learn from that. So great place to start. It's free on YouTube, but that'll get you at least to the point where what I'm talking about isn't completely incomprehensible. So anyway, pressing forward, we're just starting from a blank project here. Let's do, I don't know, the other thing I like to do is I like to do instancing from particle systems. So let's do that because that's kind of fun. All right, so I'll talk you through what I'm thinking here. So we're going to start with a sphere. This works with any shape. Toruses actually work really well with this. I heard Elbers say a while back that he'd never heard of a client who would pay for a torus. But I've actually had a lot of luck with toruses. So you know what? Just because we're going to use a torus. All right, great. So anyway, what we're doing here is we're going to turn this into a particle system. Using the particle sup, and kind of hard to see what's going on here, but if we make the viewer active, right click, display options, and then select points all, we can see what's happening here a little bit better. So what it's doing is it is generating particles out of all of the vertices in this shape. And it is generating them in some predetermined order. I'm not sure if it's going distance from the origin or what, but it's spinning in a spiral around here. So that's how it's generating them. Within the particle sup, we have some controls. Probably the most important one is we can select how many particles are generated per birth. So if you pulse the particle system, it starts over. So more or less what it does is every time it reaches its limit, it will pump out that many again, but it will also kill off enough to maintain that consistent number of particles. So right now there's only 100. What if we up that to 1,000? The behavior is technically the same, but the look is obviously quite different. So that's kind of cool. Other ways we can affect this, we can adjust the level of detail on our parent shape. So if I only give it 7 rows, notice we have a much different thing happening in the middle here. If I increase the number of rows, then we have more vertices for the particles to use as they're being generated, so it appears to be moving slower. If I add a few more columns, same thing, it just kind of, everything just sort of slows down because it has more vertices to work with. I kind of like that. Let's go with that. One other thing to do pretty much every time when you're working with particle systems is to add a sort sup in there. Where are you? There you are. So right now, I'm not entirely sure what the rule is as far as the sorting of the particles in terms of how, what order they get generated in. But if you add this sort sup, you can at least play with some other options. So if we wanted to go by a point's position according to the along the z-axis, we could select by z there. And since our camera is positioned kind of in front of this thing along the z-axis, we kind of get these these circular shapes as the cross sections of the torus get moved through. We could do by y value, so it would appear to be moving up. And then if we do x, we'll get the profile view of what was happening along the z-axis when we did by z. So just some kind of cool different behaviors you can get going there. Closest neighbor can be kind of cool sometimes, although it does seem to be the most CPU heavy. So if you have 100,000 particles plus and you throw closest neighbor on, sometimes it'll crash the project even on my desktop. But we only have 1,000 particles here, so no big deal. And it's not a particularly complex shape. I think I liked by Z the best, so we'll stick with that. I do think I want to make the torus a bit skinnier. How's that look? Cool. All right, we can work with that. The other thing I like to do with particle systems is I like to throw a transform SOP in the mix and then animate it. Because if you, let's make this bigger. Let's scoot this over here so we can zoom in and still see everything. All right, so just since it's generating particles in an order and not all at once, you can get some interesting things happening when you start to mess with the size of the parent shape and animate it. So let's say I wanted to rotate this thing along the x-axis. See how my patterns have become wildly different just because of where they are in relation to my viewpoint here. Pretty cool. If you wanted to do it along, I think Z will take us kind of clockwise. Let's see, or counterclockwise. Yeah, okay, that's cool. I like that. All right, so rather than sit here and spin the transform knob, so to speak, I'm gonna make something do it for me. So let's go ahead and get a chop. When I have an object and I'm going to spin it, all the way around within whatever my timeline is, I'll typically go to pattern, and then I'll use a ramp. That way it will just go from 0 to 360, and those are the same point, so it'll have a nice loop based on whatever my my timeline is here. First, actually, let's pick that. So I usually do 30 seconds, which is 1800 frames. Why didn't you change? There we go. And then there are other ways that are a bit more efficient than what I'm doing here in terms of just having your timeline and your number of frames all organized. So if you change one, you don't have to change a bunch, but whatever. We're just gonna do it this way for now because it's easy and quick, and we don't need a whole bunch of fancy stuff for this. So I'm gonna make sure the length of my ramp is the same as the length of my timeline. So 1800 there, that's good. And then I'm just gonna leave it. It's a nice 0 to 1 ramp. I'm just gonna leave that alone. I'm gonna use a math to change my range. So math range 0 to 1 is gonna be 0 to 360. Let's bang that out to a null just to Make good habits. There we go. All right, so I'm gonna make the viewer active there. I'm gonna grab this, I'm gonna drag it down to my transform, and I'm gonna go to the rotate on the Z axis, and I'm gonna hit chop reference, and bam. Yeah, that's nice. That is nice. I wonder if I zero this out, if it flattens out. Okay, good, it is tied to the timeline, that's good. All right, so that's pretty cool. So we have something now, a basis for the rest of it. So that we have a particle system that's essentially going to serve as our background, same as what was going on here. How how we have, I guess, basically the same thing. We have a particle system using this human head geometry, and then we have a torus, as a matter of fact, scooting around the edge there. That's what that is. So we just made a different thing to go in the background here, but that'll be our basis. So let's bang this particle system out to a null. Now let's go ahead, and while we're here, let's just grab everything, Command A, and then I'm going to turn the viewers off just to keep things efficient. All right, so now we need to build our render network and set up our instancing. So let's pick our shape. Not always, but typically do spheres. I'll bump the radius down on the spheres to not 0, 0.01. And then let's take that and let's connect it to a geometry. Cool. Then let's go ahead and get the rest of our render network set up with a camera, and a light, and a render top. Cool. And then let's bang that out to a null. There's our background. Let's turn that on, and then let's insert an RGB key. Yay. Okay, so we have the ever exciting single ball in black space doing nothing. All right, great. So all the water ripple stuff is going to take place post render, so that's going to fit over here. So let's just, since we're looking at it, let's just move this out a bit, give ourselves some room to work. Okay, but first let's get our background stuff going. All right, so in Geo, we're going to go to instancing. We're going to turn instancing on, and then we're going to use our particle system from this null here as our default instancing op. There are situations where I don't necessarily use this. I'll go one by one, but for this is fine. All right, so we're going to select P0 for our translate X value. We're going to select P1 for Y, and we're going to select P2 for Z. Cool. All right, neato. We have a particle system. Okay, so there's a few things we could do to make this a little more interesting. Sometimes like to make the scale of these things dependent on where they're at in their lifespan. So that's kind of cool. So they still have scale along the z-axis. What if I had that? Anyway, what's happening here is based on how long these particles have been alive, quote unquote, since they've been born, that will determine their scale, presumably from 0 to 1. Yeah, that's pretty cool. I might go ahead and increase the size of our spheres to begin with, since they are getting multiplied by a value less than 1 for this scale instancing. So I'm going to give them just a little more size to begin with. Might be too much. No, that's all right. We can move the camera. All right. So if I bump the camera out, cool. That's pretty good. All right. And then depending on what you're using this for, if you're using it for a projection or something, leaving the render top at 1280 is probably fine, unless you have a super HD projector or you're working with a massive LED wall, and you want to select something higher res. You can do that here. But if you're just posting to Instagram or something online, or something that'll be primarily viewed on a smaller screen, those platforms, particularly Instagram, compress detailed videos so much that there's almost no point in outputting really high res stuff. The 1280 by 720 resolution actually tends to look better when posted to Instagram than something in 4K, just because the 4K video will get subjected to a lot more compression by Instagram. Anyway, just something to keep in mind. Typically for Instagram Reels, I'll do 720 by 1280. Yeah, which is a resolution you can output with the free version of Touchdesigner, so you don't need the pro version to do that. You don't need it for this one either. If you're going to do a post, the maximum resolution on posts, when you select multiple posts, which I typically do, I'll typically output a few versions and then post them. I'm sorry, not the maximum resolution, but the aspect ratio changes to 4:5. You can't do the really tall ones anymore. That's only for reels and stories, I believe, or single posts. But if you do multiple, then this is my go-to ratio, and I kind of like the way that looks for this. So we're just going to leave it at that and keep going. If you want to, change it to anything else, we're doing fine on frame rate here. I think even on a slow machine, this would be doing okay. So if we did want to bump it to 4K, yeah, we're still running 60 FPS. Cool. But we don't need that. So let's go back to 1024 and 1280 and cool. All right, neat. So there we go. So we can make the ripples now, but there might be a few more things we want to do to our main system here to make them look better. But let's just create them and see what happens. So like most cool things in Touchdesigner, it involves a feedback loop. So let's add a null into our chain here, and then let's drag a second connector off and go to feedback. Let's add a composite out of our feedback, slide that into the line, connect our null to the composite, and then let's make sure we drag our composite onto our feedback, and boom, everything went away. All right, so let's change this to, let's try add first. We may change that to something a little less intense. Actually, let's set our feedback reset. So we're going to go keyboard and chop, turn that on, and then drag that onto the feedback, pulse button, hit chop reference, and boom, now we have a reset. This is kind of standard feedback loop fare. Let's add a level top in there. Just because we don't want, we want less than full opacity on the feedback effect, so that we don't get just this white ball as everything gets painted on. We get cool stuff like this. All right, so we have our feedback loop set up. Here is where the trick comes in. So we're going to add a displace top. Let's give ourselves a little room, and we get an error because we haven't given it anything to displace this by. We're going to connect it to itself. All right, so we get some weirdness going on. That's not really what we want. Let's just do the trick first, and then we can adjust the parameters. All right, so to get the water ripples, what you do is on the secondary connector here, the one that was from level to displace, you're going to put a slope top, and then after the slope top, you're going to put a blur top. Hey, look at that, water ripples. All right, so there's a lot of stuff we can adjust because right now we're getting this kind of weird, I don't know, grid artifact almost, and I don't like that. It's a little much for me. So let's bring down first. Let's bring our displace weight down a good bit. Okay, so as you can see, some different stuff starts to happen the lower your displace weight goes. And I've kind of experimented with all of these, but to maintain the ripple look, if we go super low with our displace weight, like even lower than this, like all the way down to 0.001, or let's see what 0.01 looks like. That's kind of nice. So if you go low with the displace weight, the way to get the ripples back is you take the strength on your slope and you just jack it through the roof, like just go into the hundreds, 200s, whatever. Okay, so you can see we're kind of getting it, but it's much more turbulent. So then we can come in and start messing with the blur. And as our blur gets lower, there we go, we start to have ripples again. Okay, so that's kind of a cool look. It's a little different than the typical water look. This is very fast. Everything's moving fast, and I like to go a little slower. So let me just show you the things that I like to play with for making this audio-reactive. The pre-shrink makes things go nuts. So I like to mess with the pre-shrink and have this jump, from 2 to 8 on a kick drum hit, and then kind of slowly taper back down. You can see it's creating some really interesting looking artifacts, both inside and outside the particles. And then as it comes back down to 1, we get more of this, small body of water thing. Let's tweak this a bit. It's not quite where I want it to be. All right, that's looking a bit more like what I want, but my slope too high. Yeah, okay, cool. I like that. So, long way to get there, but hey. Okay, cool. So we have our ripples. I guess the $64 question is, do we want to stop there, or do we want to see what happens if we do some other stuff? I say let's do some other stuff and see what happens. All right, so I'm going to include a little trick that I learned from Simon Alexander Adams, probably better known in the Touchdesigner community as Polyhop on Instagram. This is a way to create, he did it as a way to create looping noise. I just think it's kind of a handy chop setup to have on any project, because you can use these chops to control just about anything. Okay, so anyway, what I'm doing here is I grabbed a timeline chop, I added the range end option, I turned that on. I added a math chop, I set the combined channels function here to divide, so that went from 2 channels here to 1 channel. what it's doing is it's dividing the current frame by the total number of frames. So yeah, so anyway, it's giving us a normalized channel that travels through the timeline at the same rate as the frames. Hopefully I didn't just make that up. Anyway, all right, so now we're going to take that into a lookup, but we need another source for the lookup. So let's grab, we need a sine wave. Let's copy and paste that. We also need a cosine wave. When you combine a sine and a cosine wave, you get a particle in space that spins in a circle, I believe, along the XY plane. Or maybe it's the ZX plane. I don't know. Never mind. Anyway, we need a merge top. So we'll see where this all comes in handy in a second. So we merge those, and then we're going to drag that into the second input for our lookup chop. All right, cool. So now what we have are these two waves whose length is being determined by the number of frames in our project here, and then what point we're at along the way is being determined by this ratio here. And so we have our sine function up here, our cosine function down here. Now this allows us to do a bunch of stuff, but first and foremost, it allows us to animate our camera so that it goes in a perfect circle in time with our number of frames. So I'm dragging channel 1 onto the X translate value. I'm dragging channel 2 onto the Z translate value. Now we got some weirdness happening, but that's just because we have not told the camera that it needs to always be pointed at the origin. So how we do that is we grab a null component which has its X, Y, and Z coordinates set to 0, 0, 0, or the origin, and we just drag that onto our camera and then select parm look at, and then it will spin in a circle always pointed at the origin. Now the problem is this only goes from -1 to 1, and we want our camera further away than 1. So I think we had it at 7, so let's just multiply this by 7, multiply this by 7, and we should have camera spinning in a circle around our particle system, always looking at the middle. Okay, cool, there it is. So I always like there to be a little bit of movement along the y-axis, so I'll usually take one of these and paste it in the y, and then multiply it by something less than the overall distance, but it'll just give, you know, a little play and you know, allow you to see whatever the object is from more angles. All right, so what else can we do here? Right now it's pretty stark black and white. So let's do some things to make this a little more interesting. Don't like how dark we're getting on one side of this thing, so I'm going to animate the light to follow the camera so we get a consistent look. So I'm going to put my the same null, I'm going to put that as the look at for the light, and then I'm going to do exactly what I did to the camera to the light. Multiply that by the same, so it's the light and the camera are essentially one as far as this is concerned. I didn't animate the Y. It doesn't seem to make a huge difference with the light. But there we go. Now it's going to stay bright for its entire orbit. All right, so I mean we could add a Phong material in here and colorize all of our spheres. We could make them reflective. Then we have to give it something to reflect off of. That's something I do a lot, and I can make these ripples get pretty interesting. So let's do that. And the way to do that is I'm going to move this over here, and then I'm going to add an environment light into our render network. So we have a warning here. It says please add an environment map, which I'm going to do. You can do this with anything, but since we're projecting onto a bunch of spheres and we want them to look like they're reflecting an environment, we need something that's designed for that. So that format file is typically going to be not HRD, HDR, or .exr. So let's see what we got here. Now, I can't remember the names of the websites that I found these on, but there are quite a few resources for this sort of thing where you can just get these textures for free. This is kind of my favorite. I guess it's the inside of a missile launch facility, decommissioned obviously, but it always makes my particles look kind of gold. All right, so I'm going to choose that as my movie file in. I'm going to bang that out to a null in case I want to do something like add a level in there. And then I'm just going to drag my null onto my environment light, and then I'm going to select Parm environment map. Okay, nothing changed. So what we need to do now is go to Mats and grab a PBR, and then drag it onto this geo and select Parm material. Okay, so if I pulse the feedback, you can kind of see it for a second, but I think it's because we have such an intense, since we're using add instead of over or something. Let's put over on. Okay, then we can, I don't like that as much, but you can see the colorization from the environment. So what does average look like? It looks exceedingly average. What do you know? All right, so let's go back to add. All right, so I guess one thing we can do is bring the opacity down on that a little bit. I don't like what it's doing to my ripples. It's making it grainy, but oh well. All right, so we need to adjust some things in our PBR. Let me just show you what's happening here. So if I bypass our ripples feedback loop, you can kind of see what's going on here. You're getting this colorization from this movie file in, but it's not reflective at all, and that's not what we want. So if in our PBR texture we take roughness and turn that all the way down, we now have these completely reflective spheres, which just due to what that environment looks like when you place it against an all-black background, these look gold. And I think that's pretty cool. So you can mess with different things with this. If you change the emit, it will actually start emitting light, and it will become a light source. And the higher you go with, or the closer to white you go, the more washed out it'll be. Black, it has none of its own light source. You can change the base color to something if you want. Blue's kind of interesting. That's too dark. Purple's kind of interesting. Red's a little much. I do like black, but obviously not against the black background. So we'll just stick with white. All right, what does that look like if we plug our feedback loop back in? Okay, so I think we're too far away with the camera to really tell what's going on. So let me reduce this distance a bit. You know what? I'm actually going to stop the camera altogether. I'm going to move it in. There we go. Now things are getting interesting. There we go. If I bring the opacity down a good bit. and we start getting some stuff that's kind of cool. So adjusting the blur can do a lot to how these ripples look. I think they need to be a little finer. So yeah, like that maybe. I wonder if our displace is too high. Or not high enough. All right, cool. So, I mean, that's a thing. It's not the coolest thing I've ever made, but it, we have stuff happening. If we want to maybe get these slightly less intense, we can pull the brightness down on the level over here. All right, cool. So there is a thing with the ripples, and like I said, it's not, you don't have to do it this way. You can, and if we wanted, we could just take a noise, for instance, make it the right resolution. Let's get it moving just with that, I guess. All right, there we go. But yeah, if we just plug that into our null, as you can see, we still have ripples. So anyway, cool technique that can be used with just about anything, and like I said, it can be made audio reactive quite easily. So get rid of that noise. All right, so the way to make it audio reactive, I'm going to cheat a little bit. So Electronaut created this thing. It's an audio analysis tox for Touchdesigner. Where is it? There it is. It's all one word. So he made this. So I'm going to use that because it's available. I believe you can get this by subscribing to his Patreon. There are other ways to do this. This just already has all of the filter combing and just different frequencies set up and ready to go, so it makes it really convenient. Well, it's just a default Touchdesigner song playing now, so we'll just leave it. But we don't really have to do it this way, but just for familiarity's sake, let's bang everything in here out to a null. Now, what we have here, the typical way to do this, I guess, would be to set up an audio in and then put it through. Let's just click in here. I think you can see some of it. All right, well, I don't totally understand what's going on there. But I mean, at the absolute bare minimum, what you can get away with is having an audio in here and then banging that out to a null and using these channels to control some different stuff in our feedback loop, for instance. So what we're going to do here, we got our kick hitting pretty regularly, so we're going to use that as our feedback pulse. So we're going to replace the keyboard in with that. So it's going to start pulsing in time with the music, which I have off because, yeah, it doesn't really need to be on. You can kind of tell what's going on. All right, so the other thing that we want to do is, I think I want to take the snare. It looks like snare is hitting, not as often as kick, but pretty often still. So I'm going to come out of this null. I'm going to get a select, and then I'm just going to pick snare. The reason I'm doing that is because I want to do some math to the snare. And I want to go from 0 to 1. 1, 2, 15. We're going to have this adjust the pre-shrink, and I want to go a little above the 8 value. But the other thing I want it to do is I don't want it to just return from 1 or 15 to 1 right away. I want it to kind of gently slope back down. So I'm going to put a lag in there. I want no lag on the attack, so I'm going to put 0 on the front end, and then you can kind of see what it's doing. Every time it hits, it goes, ooh, ooh. I'm going to increase that time so it takes a little longer to 0.5 seconds. Yeah, that's nice. Okay, so then let's grab, actually, let's good habits. Let's bang that math out to a null. And then let's grab that, and we're gonna adjust. We're gonna go to the blur top in the displace section of the feedback loop, and we're gonna go to pre-shrink and make that a chop reference. Okay, so now we have 2 degrees of audio reactivity. Every time the snare hits, our blur is changing, and every time the kick hits, our feedback loop is pulsing. The other thing we could do that I've had some success with is just taking the level here. Let's look at what values it's. So it's kind of all over the place, but so let's just, fuck it, let's do it anyway. All right, so I'm going to take the level here, and I'm going to drag that down onto displace, and then I'm going to put that right on displace weight and chop reference. All right, so now it's pretty wild looking. Cool. Okay, so let's turn the audio on just so you can hear it with this. Okay, you get the idea. So anyway, yeah, this is worth its weight in gold. It's definitely, even if you don't stay a Patreon subscriber, you could subscribe for a month, download this tool for the cost of being a subscriber for a month, and then you got it forever. Not encouraging you to do that, but it's an option. But yeah, this tool's super handy. Just so much more robust than I guess some of the earlier methods I learned for audio reactivity. So having this as a tool is great. Really gives you a lot of control and allows you to do a lot of cool stuff in real time. I don't know if you noticed, but we're still at 60 FPS here, and we have an entire 3D particle system. We have a feedback loop, and we have real-time audio reactivity. So all of which is pretty cool. So yeah, and like I said, this can be used with anything. So I mean, there are literally infinite ways to add color to this, to add other objects, to change the behavior of this particle system. I mean, there's just the possibilities of what you can do are endless. But I do like having this little system right here, or specifically this this recursive displace in a feedback loop with the slope and the blur. I just think it looks really cool. It's really psychedelic. It's really visually compelling. It's kind of hypnotic. You can watch it for a long time. So yeah. Anyway, there it is. There's the little network we made. So I'm gonna go ahead and save this, and then I'll put a link to this under the video so you can mess with it yourself. Yeah, happy hunting.